friends, now I am going to start some application of determinants, that how we can apply determinants in finding the area of triangle. In earlier classes like class 8 and 9 we have discussed that area of triangle can be expressed as half base into height if base and height is given. Then in class 10th and 11th we have discussed that if any coordinates or if any sides are given. In class 10th and 11th we have discussed that if any sides are given, three sides of a triangle is given, that we can easily find the area of triangle by using the Heron's formula. In class 11 we have come and discussed that if the coordinates of a triangles in the Cartesian plane is given, then we can use the area of triangle. We can find easily the area of triangle by using the formula half x1 y2 minus y3 plus x2 y2 minus y3 plus x3 y3 minus y1. Then we use this formula. But now here in class 12 we are going to discuss about how we find the area of triangle by using the concept of determinants, that through determinants how we can find the area of triangle. In earlier what we have seen that the triangle is given and its coordinate is given. The coordinates of a triangle is given and then we can easily find the area of triangle if we know the formula of area triangle, that half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2 square units, and put the values of the coordinate in these form of x1, x2, x3, then we can easily find the area of triangle in the Cartesian plane. But now how we can find the area of triangle with the help of determinants, that हम determinant को use करके area of triangle कैसे पता कर सकते हैं. Now we are going to discuss about that thing only. Suppose we are going to discuss about area of triangle in determinants form, that by the help of determinants how we can find the area of triangle. Let's consider that if a triangle is given having x1, y1 coordinate, x2, y2 coordinate and x3, y3 coordinate, then by the help of determinants only we can express this as x1 y1 plus, here we have to write extra 1 here only, and the coordinates which is given x2 y2 and x3 y3 half. This is area of triangle. This is the formula of the area of triangle in the determinant form, that how we can express or solve the determinants. So we simply have to put the coordinates of a triangle in the determinant form and multiply it with half, then we get area of triangle. And remember that this quantity is always present in a mod, because area can be negative, can be positive, because it depends on the coordinate, that if coordinate, how coordinate is. If the coordinate is positive, then area become positive, and if the coordinate, if some coordinate is negative, then maybe the area become negative. But we know that area can't be negative, we cannot measure any area in negative form, so we have to take a mod in it. So this is the formula of finding the area of triangle if all the coordinates of a triangle is given by using the help of determinants. Now let's do some questions on finding the area of triangle with the help of determinants, and it is also used, this thing is also used in finding that whether the three coordinates are lying on the same plane or whether the lines are collinear or not. How we find this, that if the coordinates are collinear means they are lying on the same plane, so the area formed by this is 0, and if the area is 0 means if we put these things then we get 0, and if we get area of triangle is equal to 0, then we can easily say that all the coordinates are lying in the same plane, means they are collinear. It is also used in finding the linear expression or any lines, that if linear expression of any lines means some coordinate is given and it is said that find the equation of this line. So what we have to do, we know that area formed by a line is equal to 0. We put the coordinates in form of determinants and evaluate it equal to 0. then we get some expression, and this is the equation of a line. Because what we have used here only the concept of determinants, that area formed by a line is 0 and we get determinant. Then we evaluate it and then we get an expression, and this is the equation of a line. So now let's do some questions on finding the area of triangle, how we can prove the collinearity and expression of a line. Now find the area of triangle formed by the vertices of a triangle 3, 8, -4, 2 and 5, 1. So what we have to do, we know that area of triangle is equal to half. We put the coordinates, we have to take the mod of it also. Then we get 3, 8, 1, -4, 2, 1 and 5, 1, 1. This is the determinants. We can solve it. Half. We know how to solve the determinants. Hiding that row, first row and first column, we get the determinant 3. Then 2 ones are 2, -1. Minus sign 8. Adding these two and columns, we get -4, -5 plus 1. Hiding these row and column, -4 and -10. So we get half. 3, 2 ones are 2 minus 1, that is 1, -8, -4, -5, -9 plus 1, -14. So what we get half, here mod is there, half 3 plus 72 minus 14, which is equal to half. 3 plus 72, that is 75, and 75 minus 14, we get 61. So what is the area of triangle? We have seen that the area of triangle is found to be, so area of triangle is 61 by 2 square units. We have find the area of triangle with the help of determinant. What we have done, we have simply put all the coordinates in the form of determinants and multiplied with half sign, multiplied with half, and we get the value of area of triangle, that is 61 by 2 square units. Now question number 2, show that coordinates are given A, B and C are collinear or not. We have discussed that if the coordinates or any vertices lie on the same line, the area formed by this is equal to 0. So we simply put this coordinates in the form of determinants and evaluate to 0. Evaluate it not 0, we find the value of determinant, and if it gives 0, then we can say that the coordinates are collinear, means they are lying on the same line. So find out, let's area of triangle, half in the form of determinants A, B plus C 1, B, C plus A 1 and C, A plus B as 1. So what we get, half A, C plus A minus B minus B plus C, B minus C plus 1, B, A plus B minus C, A plus C. Taking the mod of this. So now find out A get cancel out, we get C minus B minus B plus C and B minus C, which is equal to B square minus C square plus 1. Here it get multiplied, AB plus B square minus AC minus C square, and here it gets AC minus AB minus B square minus C square plus AB plus B square minus AC minus C square. What we get? AC get cancelled out with AC, AB get cancelled out with AB, B square get cancelled out with B square, and C square get cancelled out with C square. We get 0. This quantity becomes 0. So if 0 multiplied by anything is gives 0, means the area of triangle formed by the vertices is equal to 0. Then we can say that these vertices lie on a same line, hence they are collinear. So we can see here that using the concept of determinants only, that if the determinants formed by the vertices or the area of triangle becomes 0, then we can easily prove that the points or lines are collinears lying on a same line. Okay. Question number 3, we have to find the equation of line formed by the vertices 1, 2 and 3, 6. So how we find the expression of line? We know that if it is a line, then the area of triangle formed by this line is equal to 0, because it is not enclosing any area, it does not have any height. So what is the area? Area is equal to 0. So we can easily find the expression in term of x and y. So let's say that, consider that x comma y is a coordinate which lies on this line. So what we get? We get area of triangle formed by these 3 vertices is 1, 2, 1, 3, 6, 1 and x, y, 1. Why we have written here x, y? Because we have considered that let's x and comma y lies on this line. Means ये हमारे line पे lie करते हैं. It means जो area form होगा इनसे, which we get 0. So what we get? Half. Now we solve this. 1, adding first row in first column, we get 6 minus y minus 2, 3 minus x plus 1, 3y minus 6x. So we get half. 6 minus y minus 2 3s are 6 plus 2x plus 3y and minus 6x. What we get? 6 get cancelled out with 6. 2x minus 6x we get minus 4x. 2x minus 6x we get minus 4x and 3y minus y we get 2y. Evaluate it equal to 0 because we know that area of line formed by the area of triangle formed by the line is equal to 0. So we have simply evaluated it equal to 0. So what we get? Here we are doing it. Half get multiplied on the right hand side and we get 0. So what is this? It is minus 4x plus 2y equal to 0. If we are removing this mod sign, we have to place plus minus on the opposite side. Plus minus on opposite side, but we know there is no use of plus minus side because 0 is there. So what we get? 4x equal to 2y means y is equal to 2x. This is our equation of line formed by the triangle. This is our equation y equal to 2x formed by these vertices. How we find this? We have used the concept of determinants only. That the area of triangle formed by the line is equal to 0 and we apply that principle and we get the expression or equation of a line which is equal to y equal to 2x. Hence proved.